What is up, y'all? Welcome back to another video, and in this one we're going to be taking a closer look at truffle migrations. So the first thing that I want you to do is go ahead and pop open Ganache, and we're just going to be working off a brand new blockchain. So just click Quick Start Ethereum. Nothing else we need to do here right now. Pretty much just ensure we have a brand new empty blockchain. Minimize that just to make sure it's running in the background. And what I did in this tutorial is I created a brand new empty folder, and then I just opened that in my IDE. So make sure you have an empty folder to start, and what we can do after that is we can initialize a new Truffle project. So how do we do that? Truffle init, I-N-I-T, it's short for initialize project, and just hit enter. And then that looks successful. So after you run that, you should have these folders: contract migration test and truffle config. Now, we touched on this at a very high level in the last video. However, what we're going to be doing in this video is we're going to be taking a look at this migration system, and that consists of migrations.sol, the Solidity contract, and more specifically, we're going to be looking at these migration files. So first of all, what the heck is this migration system overall? So the migration system is Truffle's way of keeping track of what changed since you last deployed your project. So what I mean by that is typically throughout the lifecycle of a project, you're going to be working on a few contracts and say, this looks pretty good. I'm ready to push it up to the network. You push it up and those contracts are deployed. And then later on, let's say the next day, you're like, okay, let me add some more contracts here. Let me build in some new features. You update your project in one way or another, and then you're ready to deploy those changes. Now, whenever you deploy those new changes, you typically don't want to deploy your entire project again. You typically just want to deploy like maybe some updated new contracts that you've written. So this migration system is Truffle's way of saying, you know what? These contracts, they're already deployed, good to go. No need to touch those again. And in fact, you don't want to redeploy those if they haven't changed, because it's just going to cost you extra gas fees. Aside from that, what it's going to do is say, however, these contracts, I haven't seen these yet. These are new to me. So whenever you deploy this, I'm going to just deploy the updated portion of your project. And if that doesn't really make sense, we're going to be taking a look at an example. Just want to give you a quick overview of kind of what's going to happen and why we're learning it right now. So that's the system overall. Now let's look at these pieces individually. So this migration contract, this is actually the smart contract that's gonna record which migrations have already been ran, or in other words, what code has already been deployed. And it's gonna say if there's a new migration that I didn't see yet, then I'm gonna go ahead and make sure that I run this and then log it here. So it's essentially the way that it tracks which code was already deployed and not. Now, this JavaScript file, this migrations _initial migration, this is essentially the JavaScript half of it. And all this is saying is this migration file right here, again, contract migrations, this is the very first thing that we're going to deploy to the network. And all of these little miscellaneous keywords, artifacts, require, deployer, deploy, we're going to be covering that in a little bit more detail in just a few minutes. But just to show you how these two things are pieced together. And now that we have an understanding of the overall system and kind of the couple key components, let's go ahead and run our very first migration, which is going to be this one right here. So what I'm going to do is I'm going to pop open my terminal, and I'm just going to run truffle migrate. Now, at this point, even though we did start our little simulation blockchain, we didn't push anything up to the blockchain yet. So whenever I run migrate, what this is going to do is Truffle is going to recognize, and you can see it right here, that whenever I said, hey, migrate, in other words, push up my changes to the network, it's going to say, okay. So the first thing it needs to do is compile this, because we only have it in Solidity code. Remember, it needs to convert it to ones and zeros before it can push it up. So after that is compiled, it says starting migrations. It's going to deploy this migration. So it essentially deploys that contract and says, this is how much gas that it costs. All right, looks good. So now Truffle has already deployed these changes to the network. And actually, if we go back in Ganache, we can see a couple changes here, and my Ethereum balance is a little bit less here. So it looks like these changes were deployed successfully. So now what I'm going to do is I'm actually going to run this command again. Now, whenever I hit enter this time, something interesting happens. Instead of compiling and deploying and doing all that again, instead this time it's going to say, you know what? Everything is up to date. There is nothing to compile. And in fact, there were no more changes to Ganache. No more blocks added, nothing happened. So why is that? Now that's because whenever we run Truffle Migrate, what we are essentially instructing Truffle to do is we're basically saying, hey Truffle, push up any new updates from our project to the Ethereum network. And on that second instruction, it's going to say, okay, well, there are no changes that happened since I last deployed, so I really don't need to do anything. So that's the basics of it. And just to hammer this home, what I want to do is I want to create one more contract, and then we're going to migrate that, and it's going to be crystal clear exactly what's going on. So I'm just going to create a new contract called bucky.sol, and I actually have right next to me that very first contract that we created in Remix. And the content of this contract, it doesn't really matter for this example. Just want to have some bare bones contract so we can figure out how to migrate it. And to do that, the first command that we can actually run is truffle compile. So what this is going to do is it's going to take any contracts that have not yet been compiled, like this one, and essentially you can think of it as taking this Solidity code and converting it into ones and zeros. And you can actually see more details of what it does. If you go to build contracts, after you compiled, you're going to see this bucky.json. And in addition to some other things, this interface meta bytecode right here, you can see that this is essentially preparing the contract, converting it into a format that Truffle can then push it up to the network. All right, fantastic. So it looks like we have our Solidity contract written. It is now compiled with all the information in build contracts bucky.json. So now, how do we get it pushed up to the network? Well, to do so, you're going to go ahead and create a brand new migrations file right here. So in your migrations directory, just go ahead and create a new JavaScript file. And the naming convention for this is actually very specific. So the first thing you're going to do is you're going to prefix the file name with a number. Now this number is going to be sequential to the previous migrations that ran. So essentially look at the number of the last migration and just add 1 to it. So this one was 1 initial migration. So this one needs to start with 2. And I say that this is important because this is actually how Truffle keeps track of which migrations have already ran and which one have not ran yet. So essentially Truffle already knows that it already ran number 1, and when we run it again, it's going to say, oh, I didn't run 2 yet, so let me go ahead and run that. Now after 2, just go ahead and write underscore, and then you can just write any human readable short description. And I'm just going to call this Bucky migration. Again, this number is the really important part, and this is just for humans to understand whenever they're quickly looking at this file name, what this migration is responsible for. So I'm going to call mine 2_Bucky_migration.js, and there we go. So now we have an empty migrations file, and what we can actually do is copy everything over from this initial migration and plop it into Bucky migrations. Now I am also going to replace everywhere it says migrations with the name Bucky. And the reason for that is because that keyword references the contract name, and I'm just basically instructing it to deploy Bucky instead. So everything else is pretty much the same. Okay. So change all of the instances of migrations to Bucky. And now let's go ahead and break this down in a little bit more detail. Now, the first thing that I want to point out is this artifacts require statement right here. Now, if you're familiar with Node or JavaScript, this may look like somewhat familiar syntax. However, I do want to point out that it is actually quite a bit different than Node's standard require statement, where you essentially just pull in code from another file. Instead, what this is going to do is it's going to pull in a contract and wrap it in a contract abstraction. Now, what this means is that with this Bucky contract abstraction, we can actually interact with it in some pretty special ways. And we'll see that later on. Just want to point out right now that there is not a direct translation from artifacts require to require. You can think of them kind of as different systems where instead of just pulling in the source code, we're actually pulling in a contract abstraction. Now, another thing that I want to point out that differs from Node or JavaScript is that this value that we pass in as artifacts.require, this is not the name of the source file. So even though we have a contract file named bucky.sol, this is actually the keyword signifying the contract's name right here. Now, why do I make this differentiation? Why is it even important at all? Well, believe it or not, in these Solidity files, we can actually have multiple contracts in the same file. For example, we can create another contract in this file named Wendy. This might be kind of bad convention, but for example, just want to show you what's possible. Now, in that case, we could just put Wendy right here and it would work all the same. But either way, what I want to point out is that typically, or I don't want to say typically, a lot of the time you have your contract name the same as your file name right here. And what people do is they just try to require in the name of the file, like Bucky, as in bucky.sol. But if you ever get issues, it's probably because you need to pull in the contract name instead. So in this case, if we did have that Wendy contract in there as well, what we could do is we could actually pull that in just like this. So requiring in Bucky and requiring Wendy, just like that. Now, another thing that must be included in these migration files is this module.exports. So module.exports, it needs to export a single function, and this function takes deployer as its first parameter right here. Now this deployer object, you can kind of guess it's Truffle's object that comes with some functions useful for deploying smart contracts. Now we're going to be taking a closer look at each of those functions as we need them later on. As you can see, the first one is kind of simple. It just has a deploy function, which we pass in a contract, and it essentially is just going to deploy this to the Ethereum network. Pretty simple. And the last thing that I want to mention before we actually deploy this is that you may also see some other values being passed into this function. For example, you may see network being passed in, and this is just if you want to deploy, but you need some more context around your deployment. In this case, you can do something like if network is equal to like a development network or something, then you can do some kind of deployment. Otherwise, let me just do this. You can do something else. So again, there is a little bit more to this, but again, I don't want to kind of just focus on all the nitty-gritty details before we actually need those features. So for now, this looks pretty good. So what I'm going to do now that we have everything set up is I'm going to go ahead and run Truffle Migrate again. Now remember, if everything worked correctly and I set everything up correctly, then what this should do is Truffle should recognize that we already did run that first migration, so no changes needed there. However, this new migration, which is deploying this Bucky contract to the Ethereum network, this has not ran yet. This is not yet on the network. So these are the only changes that it should push up. So let me go ahead and hit enter, expand this a little bit. All right, so we ran Truffle Migrate. Looks like it compiled bucky.sol. And all right, looks like it is deploying this Bucky contract and only deployed one contract. All right, so far so good. And just to verify that, if I run Truffle Migrate again, since it now deployed all those changes, it should now say everything is up to date. And just to verify that that all worked, we now have some new blocks looking good. Now, the last thing I want to talk about regarding Truffle migrations is actually how to reset your migrations. In other words, if you do want to run all of your migrations from the very beginning, even if you ran them before, then how you would do that. Now, before we just hop into that, I want to show you an example of when this would actually be useful. And for that, let me go ahead and pop open my terminal, and I'm going to run Truffle Console just so I can interact with that Ganache blockchain. And to see what's going on here, let me go ahead and get a reference to that contract abstraction. And by the way, all a contract abstraction means, if that terminology is getting kind of confusing, is just saying that, hey, I want a way to interact with this Ethereum contract, and I want to do it through JavaScript. So pretty much just allows you to interact with Ethereum contract through JavaScript. So to do this, I'm going to say let instance equals await Bucky, which is the contract, and I want to get a reference to the deployed contract. So again, essentially just abstraction for this deployed Bucky contract, storing it in a variable called instance. And then this instance, if I log it out, you can see it's pretty much just a JavaScript object that is essentially a reference to our deployed contract. So right now, I'm gonna say, let's go ahead and just get the age of this deployed contract. So we can do instance.getAge, and all right. So this is kind of surprising. Instead of just a number, which, that's another thing. So we initialized this contract and Bucky didn't have any age. And actually we didn't even set an age. So whenever this contract is first initialized, if we don't give age an explicit value, then it's just gonna initialize it by default to the default value, which is 0. So why don't we just see 0 print out here? So this is another interesting point about Solidity and really Ethereum overall, and that is that the Ethereum network can handle very large numbers. Now, to make those numbers JavaScript compatible, what we do is we essentially convert them to something called a big number, and that's what this BN stands for right here. And later on, when we're actually writing a full dApp, I'll show you how to convert these big numbers to something that's more usable in our dApp. But for now, just want to say that this is indeed storing that numerical value. It's just kind of a JavaScript compatible version of that Ethereum number. All right, so whenever this contract was initialized, Bucky's age did get set to 0 by default. Now, of course, what we can do is we can say instance, and we can set age to something like 300. And then, okay, whenever I run get age again, now you can see that, and it's kind of weird because this is stored in an object and the value is actually the first item in this list. But if you look, kind of squint your eyes, you can see that the age of Bucky after setting it to 300 is now indeed 300. Okay, fantastic, but what are we doing setting and getting Bucky's age for? You know, this doesn't really seem related to migrations at all. Well, I mention this because let's say that we realized after interacting with this contract that this isn't the exact logic that we want. Instead, whenever this contract is first created, we want to initialize Bucky's age to, well, we're not sure yet. Let's give the deployer the flexibility to set their own age. So what we can do is we can introduce a concept called a constructor. And this constructor function, again, if you're familiar with, well, a lot of different object-oriented programming languages, you're probably going to understand the concept of this constructor. But for those who don't, it's really just an optional function that gets declared, and any code that is inside here, it's going to be executed as soon as your contract is first created. So think of this code right here essentially as contract initialization code. Initialization code. There you go. That's a tongue twister. So what can we do in this case? Well, let's say that whenever this contract is first created, in other words, first deployed to the network, then we're going to allow the user to pass in an age, and that's going to be Bucky's initial age. So how do we do that? Well, it's actually the exact same as this function right here, but let's just go ahead to change things up a bit. We'll say that age is equal to the age that we pass in. That's actually a little bit better than X. And let's say we want to update that right there too. Okay, so we made a few changes to this age contract right here. Most specifically, or most notably, I guess you could say, is that we added this constructor. We also changed the variable name right here. Now, let's think about this a bit, because the JavaScript code or the migration file responsible for deploying this contract right here, it actually already ran. So is Truffle going to know to actually run this again with our updates? Well, let's find out. So what I'm going to do is I'm going to first compile this contract again. Now, it is going to recompile this because it does see, oh, I compiled this before, but there were some changes since then. So I'm going to go ahead and recompile it. Basically, it now converted this to a different set of ones and zeros. So this file has been updated right here. But now, once that's compiled, let me go ahead and run Truffle Migrate. And all right, everything is up to date. Okay, so it did compile it, but it didn't push these new changes up to the network. So why didn't it do that? Well, it turns out, according to our migration system, it is just working correctly, because we said that whenever there is a new migration that you are unaware of, then just go ahead and run the code in this migration file, specifically in this function right here. And this is essentially how you migrate those changes. Now, it already ran migration 1 and it already ran migration 2. So even though this contract was updated, the migration system, it didn't really care, because you can update it all day. No matter what, it already ran migration 2. So if we want to update this contract, how do we go back and say, you know what, Truffle, I know we told you only run new changes. However, we did make changes to this. So if you can go ahead and rerun these migrations, then that would be great. Well, we know that it won't work with Truffle Migrate as is. However, what we can do is we can send in the flag reset. Now, whenever we run Truffle Migrate reset, then what this is going to do is instruct Truffle to run all migrations from the very beginning instead of just running the new migrations, since the last migration was successfully ran. So now let me go ahead and run this again and check it out. All right, so it looked like it tried to migrate this, but I'm getting a weird error here. Error, invalid number of parameters for undefined, got 0, expected 1. Okay, so somewhere it was expecting a value and we weren't passing in that value in. So check it out. Before, when we didn't have this constructor, we could just take this contract, deploy it up to the network, and everything was fine. Now, however, since we made this update, what's happening is that as part of the deployment process, or in other words, the very first time that you push this up to the network, you have to give Bucky an initial age. And that is part of the constructor logic. So that is why in this, it's saying, hey, even though it doesn't, or maybe it says it somewhere that it's the constructor, but it's essentially saying, hey, as part of this initialization, I was expecting a value for age, which was this value right here, but instead I got 0 information, 0 values. So how do we deploy this with this constructor requirement right here? Well, what we can do is we can hop back into this migration, and in this deployer.deploy, the first argument is always going to be the contract abstraction right here. And then the second one, let's just say 90, this is going to be the value for the constructor. So if this works correctly, then what we should do when we run this command again is it should deploy the same contract. However, then when we tap into it and check the initial value of Bucky's age, that should be 90. So now let me go ahead and clear this and try running it again. And all right, so we're resetting, and all right, this looks pretty cool. Total deployments of 2. So now let's just go ahead and clear and make sure everything worked correctly. So I'm gonna tap into this again, hit Truffle Console. All right, let's go ahead and do the same thing, where we are going to want to get the deployed reference to our Bucky contract. And now that we got a reference to our new contract, if we do instance.getAge, unlike before when it was 0, hopefully we see 90 right there. So again, a couple notes, just a reminder, is that whenever we already ran migrations, but we want to explicitly rerun those migrations, then what we could do is we can run Truffle Migrate again by passing in the reset flag. This is going to indicate no matter if you ran those migrations or not, just go ahead and reset from the very beginning and rerun those again. And another thing is that when we have a constructor during deployment, in order to essentially pass in values to that constructor, you just pretty much just add those values right after the contract name right here. All right, so I think that covers everything that we need to cover right now in terms of migration. Again, I know this isn't the most interesting stuff. You probably want to get into, creating your own tokens and NFTs and so on and so forth. However, I did want to take a tutorial and cover all this because it is going to save you a bunch of headaches in the future by understanding all of this in a little bit more detail. But for now, thank you for watching. Don't forget to subscribe, and I'll see y'all in the next video.